Okay, one last video, and you shouldn't play this in class. This will just be on Edmodo, hopefully. I just wanted to go through questions from 15 down to 20, just to get you guys started, because these questions are very, how do I say this, tricky to begin with, but once you get rolling, they aren't that hard. So I'm not going to solve these questions for you, but I'm just going to give you some prompts and some hints of how to figure it out. And generally, you can roll up from there. I would say the most helpful way of thinking about this is putting things in terms of, actually, let's rephrase that, reviewing indice laws and how indices work. That is a big, big component. So that's year 9 work, thinking about indices and how they work and changing the nature of how things look. And so, for instance, with this one, I think this is a very good example. Another way I can write this is 2x plus 50 times 1 over x. And 1 over x, anything 1 over itself, 1 over that thing is, in case you haven't forgotten, x negative 1. Okay? So I can write this as 2x plus 50 x negative 1. Now, when you go to differentiate that, that negative 1 will come down, and if you're minusing 1 from that, that will be minus 2. So I will just do it for you. Let's go P dash, because I'm feeling a little bit lazy. That would be 2 plus, well, it's going to be negative 1 times that, so it's going to be negative 50 x negative 2. Okay? From there, you can solve the rest. This one, I think this looks really hard to begin with, but it's actually not that hard. You're actually given dy dx, not y. If you were trying to differentiate this, it would be a lot harder above your skill level currently, but not impossible. You're just trying to find, question 15, find the stationary point. You just make this equal 0. And that's not going to be that hard. You can solve it from there. You can figure out what the x roots are. So that's not that hard. This one, I would say, is the hardest one of the bunch. Now, I don't know if I'm going to give you the helpful advice that you want here, but this is how I would solve it. I would put everything as a fraction and solve it like that and work with some fractions. I know some of you don't like fractions. I personally don't like working with fractions either, but I don't know how you're going to get rid of this denominator that's 8 and bring it forward or anything. I am just really bemused. So I would totally rewrite this as 1 over 8 h squared minus 2 over 8 is going to be simplified to 1/4. So we can write that plus 5 over 8. And from there, I would differentiate that and bring the 2 down to here. Oh, I can't help myself. I'll just help you. Bringing the 2 down, that would be 2 over 8. And that's just going to be 1, so it's going to remain the same. And that's going to go away. And then you're going to end up with something like this. And that simplifies to 1 over 4 h minus 1 over 4. And that's the differentiation of that. So not as complex as I think, but you have to think in terms of fractions, which some of you are better at others, but you've just got to simplify that, because that's really hard to work with. Next one. Okay, I always hated this stuff. I hate when pi is in there. It's just a mess. But essentially, r is your x in this one. Okay, v is your y, r is your x, and you're differentiating r. Okay, because r is the, I'm not going to get into a detail now, but it's the most common variable in this trait. So if I go v dash, that's just going to go 40. That 3 is going to come down, minus 3 pi r squared. And you guys can take it from there. Okay? Determine the nature of it, correct your decimal place. I guess you would sub that into your calculator and take it from there. For the stationary point of r equals thing, so you'd make that equal 0. You should be able to solve that. Okay? This one, I am going to do go back to question 8 and solve it similarly. Sorry, question 17. Sorry, it's very late. I would put this as 2 pi r plus 120 r negative 1. And then if I'm differentiating that, 2 pi plus that negative is going to come down. That'd be negative 2. Just to point it out to you guys, I always used to make this mistake in year 11 and 12. I don't know why I made that 0. It's not 0. You're always minusing 1. Okay? You might get confused with integration, our next topic, but you're minusing 1 here for now. Okay? And lastly, so I think some of you might have forgotten how to write the square root as a indice. What that actually transponds to, the x will stay the same. I'm going to put it in brackets, 3,600, sorry, minus x squared to the power of half. If I am going to differentiate this, it's going to be a mess. Do they want me to? Oh, they do. Okay. There's a few different steps here. You've got to use the chain rule and the product rule. Oh, okay. How about I'll pause the video now. I'll stop the video now, actually, and I'll do this in a separate video down below.